Dear students, till the offline classes commences, your online classes will continue. So, do refer the group and at the same time start writing all the notes which I am going to forward. So, in today's session I will be starting one more chapter which is titled Oscillation, which is chapter number 14. There are a few other chapters in between which are remaining, so that will be completed. So, as this chapter is important from the exam point of view, I am going to start with this particular chapter called Oscillation. So, I am going to start with the illustration for this particular chapter. So, the first illustration that I am showing is a revolution of the earth around the sun and the revolution of the moon around the earth. So, what we get to notice here is the revolution of the earth around the sun. Now, this is more of circular motion, not exactly a perfect circle, but it is almost a nearly circular motion, and this type of motion is repetitive. Can you see that? It takes one same time to complete one revolution and then it repeat that motion again and again. It's a repeated motion. So, let us say one more motion which is repetitive. Okay. So, again you can see the revolution of the moon around the earth. So, this is also again repetitive, where it takes exactly 27.3 days to complete one revolution around the earth, and in this case it takes 365.3 days to complete one revolution around the sun. So, let us say some more repetitive motion. So, in the case of a clock where there is a pendulum, the pendulum again it undergoes a to and fro motion. So, this is also repetitive. We have done experiment pertaining to simple pendulum. So, there also you can say when a pendulum is made to oscillate, it repeats its motion. So, let us see one more illustration. So, where we have a musical instrument, a guitar, in which when these strings are plucked, you can see very clearly here. So, how that string it vibrates. So, this is again another repetitive motion. So, therefore, what exactly a periodic motion? So, periodic motion, any motion which repeat itself is called as the periodic motion. Okay. So, what is a periodic motion? Any motion which repeat itself is called as the periodic motion. And example for the periodic motion I have already given just now. For example, revolution of the earth around the sun, revolution of the moon around the earth, then vibrating strings in musical instrument, oscillating simple pendulum. In vehicles, in automobiles, there is a part of an engine which is called piston, and when that engine works or when the vehicle moves, that piston moves up and down. This is periodic motion. Okay. Even the motion of the particles which we cannot see here, correct. So, whenever I am going to talk, the particle in air, they vibrate about its mean position. So, any repetitive motion is called as periodic motion, and I have already given example for it, and this is again a question from the previous examination. So, that is why it is very important. Then whenever particle vibrate, correct, or whenever particle completes one circular motion, we can always calculate two important quantities. One, the period of oscillation, and the other is frequency of the periodic motion. Now, what do you mean by time period? So, time period means time taken by the particle to complete one vibration is called as time period of vibration. How to calculate the time period of vibration? Time period of the vibration is equal to, it is the ratio of number of oscillation or number of vibration divided by the time taken. This is how we calculate. So, how to calculate the time period of vibration, time period of oscillation? It is the number of vibration or number of oscillation divided by the time taken for it. So, that will give you the time taken to complete one oscillation. I think I have time taken to complete one oscillation means the total time taken divided by number of oscillation, okay, number of oscillations or vibration. Okay. So, how do you calculate time period? Time taken to complete one oscillation. Okay. If small t is the time taken for n number of oscillation, then you divide that by n. T is the total time taken for n number of oscillation, then the t by n will give you time period, which is normally measured in terms of a second. How to find frequency? Frequency is exactly opposite. It is number of oscillation or vibration divided by the time taken. That means the number of oscillations completed in 1 second is called the frequency of oscillation. So, which is exactly n by t. It is a per second is the unit, per second, or you can even measure it in terms of hertz is the SI unit of it. So, how to define time period of oscillation? Time taken by the particle to complete one oscillation is called as the time period of oscillation, and number of oscillations completed by the particle in 1 second is called as the frequency of oscillation. So, T is equal to T by N, or F is equal to N by T is the two important formulas which you have to remember. So, whenever the vibration takes place, there is something called initial position, okay, initial, and that initial position is called the mean position, okay. Initial position from which the particle starts vibrating, oscillating is called the mean position, and when it starts oscillating, it goes to the extreme. So, this is called the extreme position. This is the mean position, this is the extreme position. So, from the mean position to the extreme position, we can find the displacement. This is called the maximum displacement of the particle from the mean position, and that is called the amplitude. So, very important term. It is denoted by capital A, and its SI unit is a meter, and it is a vector quantity. So, how do you define amplitude? What is amplitude? Maximum displacement from the mean position. From here till how much maximum it goes from the mean position. Now, that is called as the amplitude. So, we have three important terms. One is time period, frequency, and amplitude. What is time period? Time taken by the particle to complete one oscillation, and then frequency of oscillation is nothing but the number of oscillations completed by the particle in 1 second is called as the frequency of oscillation. And what is amplitude? Maximum displacement of the particle from the mean position is called as the amplitude. So, these two are important questions from the exam point of view. So, we have a few easy numericals that have appeared in the model paper. So, we will solve them easy and simple. So, one by one. So, if calculator is required, we will use the calculator, otherwise we will try to calculate manually. Okay. Now, on an average, the human heart is found to beat 75 times in minutes. So, therefore, the number of times the heart is going to beat is 75. And here I am going to write the formula. So, T is equal to T by N, or F is equal to N by T. So, N is equal to 75 times in minute. So, in a time of 60 seconds, calculate its a frequency. So, frequency is given by the number of times the heart is going to beat. So, again, heart is a good example for the periodic motion where it's going to pump the blood. It's given here 75 times, in 1 minute. Okay. So N divided by T. N is 75 divided by 60. Now 15 fours are 60, 15 fives are 75. 5 by 4, it's 1.25. 25 what? Hertz. So this is the frequency of pumping of the heart, or the frequency of the heart beats actually. Okay. So 1.25 it's given. That means it's going to beat 1.25 times per second. So that's how we can understand that particular value. So easy question. It's not a 5 marks numerical. It's basically either 1 mark or 2 marks question. So we'll see one more question. A particle takes 32 seconds. So time is given 32 seconds. So this is the first problem. This is the second one. So T is given 32 seconds to make 20 oscillations. So number of oscillation is 20. Calculate the time period and the frequency. So we'll calculate the time period. T is equal to T by N. T is 32 by 20. See, 32 by 2 is 16 by 10, which is 1.6 seconds. So that's the time period. Frequency is always a reciprocal of the time period, which is 10 by 16, exactly opposite, which is same as 5 by 8. And when you divide here, it's a 0.50 means 86, or 48, 20 means 8 2s are 16, 4 remaining. Then 40 means 85, so it's a 0.625 hertz or per second. So you should be good in your basic maths, which is again very useful, especially for the competitive examination. So this is the way to calculate. Don't use a calculator every time, whenever the numbers are very simple and easy. So let's see one more question. If the frequency of the oscillation is 50 hertz, so frequency is given 50 hertz. What is the period of oscillation? So you have to calculate the value T. So T is equal to 1 by F, 1 by 50. See, either you can divide it as it is, or we can even make like this. And I'll multiply by 2. When I multiply by 2 here and divide by 2, I'll get 2 by 100. Multiply by 2, multiply by 2, you'll get 2 by 100. And 2 by 100 is an easy way to simplify, which is 0.02 watt second. So hope I understood. So this kind of numericals will appear in the examination, maybe for 1 or 2 marks question, depending on. So for example, this is a 2 marks question where we have to calculate time period as well as the frequency. So I'm going to consider the example of the simple pendulum, then we'll understand what exactly this question is all about. So this is the mean position and this is the extreme position. So as the pendulum oscillates like this, and again this is another extreme position, okay, and the pendulum oscillates like this. See, when it oscillates like this, at the extreme position, the pendulum comes to rest momentarily, only for a moment. So therefore, its velocity here is 0. Its velocity is 0 here. Correct? At the extreme position, it comes to rest for a moment. So therefore, its velocity is 0. And here the velocity is the maximum. Now see this point here. As it moves from the mean position towards the extreme position, is there any change in the velocity? Yes. Is the velocity increasing or decreasing? It is decreasing. If there is a decrease in velocity, definitely we say that the body possesses acceleration. And what is the direction of that acceleration? Since the velocity is decreasing, the acceleration is always opposite to the motion of the body. See, the body moves from the mean position to the extreme position, whereas the acceleration is from the extreme toward the mean position. Why it is opposite direction? Because the velocity of the body as it moves away, it decreases. So we know that when a body is thrown upward like this, see, velocity decreases. So therefore, the direction of the acceleration, it's always downward towards the center of the earth, and we call that as acceleration due to gravity. So what is the reason, or what makes this acceleration, or how this acceleration is produced? Because whenever the pendulum moves away, there will be a force acting in the opposite direction, and that particular force is called as restoring force, opposing force. So it is this restoring force which brings the pendulum back to the mean position, and because of this restoring force, there exists an acceleration, and that is A. And now you can see the displacement of the bodies from the mean position to the extreme position. That is the displacement, okay, which I am going to write it as y. You can consider it as x as well. Whereas the acceleration is from the extreme position to the mean position. To the mean position. So that is the force as well as the acceleration. So here we find that this force is directly proportional to the displacement. Force is always directly proportional to the displacement. More force, more displacement. Less force, less displacement. And if there is no force, there is no displacement. And in opposite direction. So force is always acts in a direction opposite to the displacement. So that's why it is the minus sign. And we write a constant, which is F is equal to K into Y, minus K into Y. What is that K called? K is called restoring constant, or it is also called as the force constant. But we know that the force is always a mass into acceleration, which is minus K into Y. Therefore, acceleration is equal to minus K by M into Y. And from this we can come to a conclusion that the acceleration is always directly proportional to the displacement of the particle from the mean position, and it acts towards the mean position. The minus sign indicates that the acceleration is always towards the mean position or opposite to the displacement. And any such type of periodic motion in which if this condition is satisfied, then such type of motion is called as simple harmonic motion. So what is simple harmonic motion? A simple harmonic motion is one in which the acceleration of the body is directly proportional to its displacement from the mean position and directed towards the mean position. So therefore, simple harmonic motion is one of the periodic motion. And what is periodic motion? Any motion which is repetitive is called as a periodic motion. So question is whether all simple harmonic motions are periodic in nature. The answer is no. For example, revolution of the earth around the sun is a periodic, but it is not simple harmonic in motion because it doesn't satisfy this particular condition. Oscillation of a simple pendulum. Yes, it is both periodic as well as simple harmonic motion. So all simple harmonic motions are periodic nature, but all periodic motions are not simple harmonic in nature. So that is what the definition, so you need to remember. So therefore, define simple harmonic motion and give example. So repeatedly asked question. So this is the definition. The definition of the simple harmonic motion: a particle is said to have simple harmonic motion if the acceleration of the particle is directly proportional to its displacement from the mean position and directed towards the mean position. Directed means the direction of that acceleration is always toward the mean position. So, go through the definition again. A particle is said to have simple harmonic motion if the acceleration of the particle is directly proportional to its displacement from the mean position and directed toward the mean position. That minus sign indicates that the acceleration is opposite to the displacement. The displacement is from the mean position toward the extreme, whereas the acceleration is from the extreme position toward the mean position. They are exactly opposite. So, that is why that minus sign. And this is the condition under which we call the motion as a simple harmonic motion. Examples: don't give example of revolution of the earth around the sun, which is not simple harmonic in motion. You can give vibrating strings in musical instrument is a simple harmonic in motion. Oscillating pendulum of a clock is a simple harmonic in motion. Then vibrating piston in an engine is a simple harmonic in nature. So, these are the illustration for simple harmonic motion, but the revolution of the earth around the sun, revolution of the moon, correct. So, these are all periodic in nature, but they are not simple harmonic motion. Why they are not simple harmonic motion? Because they do not satisfy this particular condition. Okay. So, what is the condition to call it as a simple harmonic motion? Acceleration of the particle is directly proportional to the displacement from its mean position and directed towards the mean position. Mention the characteristic of a simple harmonic motion. There are three characteristics. Characteristic number 1, the simple harmonic motion is a periodic in nature. The second one, the acceleration of the particle is directly proportional to the displacement from the mean position and directed towards the mean position. And the most important, the time period and the frequency of the oscillation is independent of the amplitude. That means if you take a simple pendulum, whether you take a small amplitude or large amplitude, the time period and the frequency remains the same. Time period and the frequency is independent of the amplitude of oscillation. What is amplitude? Maximum displacement of the particle from the mean position. So, these are the characteristic. Simple harmonic motion is periodic in nature. The acceleration of the particle is directly proportional to its displacement from the mean position and is directed towards the mean position. And the third one is the frequency and the period of oscillations are independent of its amplitude. It does not depend on the amplitude. Again, another important question. So, therefore, the year which is mentioned tells you how important that question is. So, another question that has appeared in the examination is the one which I have already explained. Show that in simple harmonic motion, the acceleration is directly proportional to its displacement at the given instant. So, what you need to do is you start from the force. F is proportional to minus y and F is equal to minus k into y. K is called force constant or restoring constant. Force is nothing but mass into acceleration, which is minus k into y, and rearrange for acceleration A is equal to minus k by m into y. K is a constant for a given body, m is constant. That is why A is proportional to minus y. So, this is what we need to prove, that the acceleration is directly proportional to its displacement from the mean position, and the minus sign signifies that it is always directed towards the mean position. So, hope you have understood whatever the topic that I have explained. So, mainly I have started with the periodic motion and certain terms like period, frequency, amplitude, and then an important types of periodic motion, which is simple harmonic motion. So, a lot of equations are coming up in the next class, and all the numericals which are there in the study material. So, that will be solved in the class. I am going to continue the remaining of the oscillation in the next class. Okay. So, till then, take care.